Hi everyone, this is your math guru. In this video, I'm going to show you how to find the missing angles by applying various geometry of angle rules and also some circle theorems. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have to find the angle x and angle y. Given the diagram, we know that because all the corners of our quadrilateral is touching the circumference of the circle, then we know that the figure EHGF is a cyclic quadrilateral. One of the properties of a cyclic quad is that the opposite angles are supplementary, or they add up to 180. So to find x plus 83 degrees is equal to 180 degrees, and the reason being the opposite angle of a cyclic quad. So we have this angle as shown in the diagram. The opposite angle is 82 degrees, must be equal to 180 degrees. So therefore, to find x, we have x taking 83 degrees from both sides. We have 180 degrees minus 83 degrees. Therefore, the value of x equals 97 degrees. Likewise, to find y, we have the angle y as shown, and the opposite angle is the angle at E, which is 105 degrees. So using the same circle theorem that states that the opposite angle of a cyclic quad are supplementary, we have the angle y plus the opposite angle 105 degrees is equal to 180 degrees. Same reason, opposite angle of a cyclic quad is supplementary. So therefore, the value of y, taking 105 degrees to the other side, we have 180 degrees minus 105 degrees. Therefore, the value of y is 75 degrees. Let's look at the next example. In the next example, we have to find the angles x, y, and z. I'm going to start with the quadrilateral AB, C, and D. If you note, the corners A, B, C, and D are touching the circle, and so therefore the quadrilateral ABCD is a cyclic quad. One of the properties is that the opposite angles are supplementary. So we have the angle at A, the opposite angle will be the angle at C. Therefore, to find x, we have angle x plus the opposite angle, which is 82 degrees, will give us 180 degrees. And the reason is the opposite angle of a cyclic quad. To find x, we are going to take 82 degrees to the other side. We have 180 degrees. It becomes a minus 82 degrees. Therefore, the value of x is 180 minus 82. That will be 98 degrees. The next step is to find the angle y. I'm going to clean off, okay? If you look at the triangle ABD as shown, we can apply the geometry of angle rule that states that the sum of angles in a triangle add up to 180 degrees. So therefore, to find y, I have 40 degrees, 40 plus 82 degrees plus y is equal to 180 degrees. And that's because the sum of angles in a triangle ABD must always add up to 180. We have 40 plus 82, that's 122 degrees, plus y equals to 180 degrees. Therefore, to find y, I'm going to take my 122 to the other side. It becomes minus. So therefore, the value of y equals 180 degrees minus 122 degrees will give us 58 degrees. Also, if we look at the triangle BCD as highlighted, we can use the same geometry of angle rules that states that the sum of angles in the triangle add up to 180. Now, because I have x to be 98, I can say 62 degrees plus 98 degrees plus the angle at z equals 180 degrees. And the reason being, sum of angles in the triangle BCD. 62 plus 98 degrees, that will give us 160 degrees, plus my z equals 180 degrees. And to find z, I'm going to take my 160 degrees to my right hand side. So that will be minus 160 degrees. Therefore, the value of angle z equals 180 minus 160, that will be 20 degrees. Let's look at the last example. In my last example, I'm to find angles x, y, and m. Note that because triangle PQS is an isosceles triangle, and we know that the base angle of the isosceles triangle are equal, so we have angle P, S, and Q, this angle, to also be equal to x. And the reason being, we have isosceles triangle PQS. So I'm going to call this angle x, such that if I look at the angle triangle PQS, I'm going to have 110 degrees plus x equals 180 degrees. And the reason being, the sum of angles in a triangle add up to 180 degrees. I have 110 plus x will give us 2x equals to 180. Therefore, 2x, taking my 110 to my right hand side, I have 180 degrees minus 110 degrees. 2x equals 70 degrees. That's 180 minus 110. Dividing both sides by 2, I'm left with my x equals 70 divided by 2. That's 35 degrees. To find y, if you look at the quadrilateral PQ, R, and S, all the corners of the quadrilateral touches the circle. So therefore, that's a cyclic quad. And we know that the opposite angles of a cyclic quad are supplementary. So what that means is angle y plus 110 degrees is equal to 180 degrees. And the reason being, opposite angle of a cyclic quad. Therefore, taking my 110 to the other side, I have 180 degrees minus 110 degrees. Therefore, the value of y equals to 70 degrees. To find the value of m, if you look at the triangle QRS, I'm going to highlight that. I have QRS as shown. Because of the equality mark, we know that QR is equal to RS, and what that means is that triangle is an isosceles triangle. And because it's an isosceles triangle, base angles of an isosceles are equal, so the angle RQS is also equal to m. So I have angle RQS is equal to m, the reason being isosceles triangle RQS. So therefore, we know that the sum of angles in a triangle add up to 180. So I have the value of y, angle y plus m equals 180 degrees. The reason being, sum of angles in a triangle RQS. I have y to be 70 degrees plus m, or I'm going to say m plus m is 2m, equals 180 degrees. Taking my 70 to the other side, I have 180 degrees minus 70 degrees, and that will give us 110 degrees. Dividing both sides by 2, I have 2 into 1. Therefore, the value of m equals 110 degrees divided by 2. That will be 55 degrees. Thanks for watching. Bye.